Alright, so here today we're going to be learning about the law of cosines. I'll start off first with a derivation of where it is coming from. So let's start off with a triangle. This does not have to be a right triangle, it could be any type of triangle. We'll label it how we label it, the law of sines, A, B, C for our angles, and little a, little b, and little c for our opposite sides. In order to do this, I'll need to drop an altitude and create two right triangles. Alright, so first what I'm going to do is I'm going to look and see what the cosine of C is. In order to do that, I'll need to go ahead and label its adjacent and opposite side. So let's call this adjacent side, and this triangle over here on the right side, let's call it E. We'll call its opposite side F, and let's just go ahead and call this little guy over here G. So cosine of C is equal to adjacent over opposite. Looking at kind of how we label this, we can also say that B is equal to G plus E. And let's see. A cosine of C is going to be equal to E. Looking again at this same right triangle on the very right side, we can go ahead and set up an equation for sine of C as well. So sine of C is equal to opposite F over hypotenuse A. Therefore, F is equal to A sine of C. Alright, so looking at this, let's go ahead and get an equation for G as well. So using this equation right here, we're going to get an equation for G. So if B equals G plus E, then G must equal E minus B, which we have an equation for E, that's A cosine of C. So therefore, G must equal A cosine of C minus B. Alright, I think we got one more little kind of thing we want to look at. On the very left triangle, G squared plus F squared would equal C squared using the Pythagorean theorem. So what I kind of have is, I have basically three equations that are for E, G, and F. And we can use those into this Pythagorean equation we just had to set up an equation that relates all three sides with an angle in this triangle. So G squared is going to be A cosine of C minus B squared plus F squared, A sine of C, and that's equal to C squared. Alright, so this G right here is this, and this F right here is that. Alright, go on. Now, we have an equation that deals with the sides of this triangle and an angle C. And this right here is kind of the law of cosines, but this is not how you'll normally see it represented. We'll actually need to simplify it a little bit in order to having a kind of a working equation. Alright, so what I'm going to do is I'm going to FOIL out the first part. So A cosine of C minus B times A cosine of C minus B. I'm going to add that to A sine of C squared, and that's all equal to C squared still. Now we're using front, outer, inner, last. That looks like A squared cosine squared of C. That was front. Outer would be minus BA cosine of C. Inner minus BA cosine of C, and last would be plus B squared. We're going to add it, so if I square A sine of C, that's just going to be A squared sine squared of C, and that's equal to little c squared. Alright, so I'm going ahead and move my triangle away from this so you can kind of see what's coming up at the very last. Looking through this equation, I got some like terms, like for instance these two are like terms. I can combine them. Minus BA cosine of C and minus BA cosine of C would make minus 2ba cosine of c. Alright, so I'm going to write that in. A cosine squared of c minus 2. And we'll go ahead and just put this in alphabetical order as well. Cosine of c plus b squared plus a squared sine squared of c is equal to c squared. Looking through this equation, I also see some trig identities. Sine squared plus cosine squared is equal to 1, and they both have the same factor, a, attached to it. So I'm going to go ahead and I'm going to bring an a squared out. So that would be cosine squared of c plus sine squared of c minus 2ab cosine of c plus b squared is equal to c squared. Alright, so then this right here is equal to 1, and kind of start going ahead and combining everything out. A squared, and I'm going to do this again in alphabetical order, is plus b squared minus 2ab cosine of c is equal to c squared. Alright, well, we have one of our law of cosines. Formally writing out all of this, let's see. Doing the same derivation except for a squared instead of c squared, we would get a squared is equal to b squared plus c squared minus 2bc cosine of a. B squared is equal to a squared plus c squared minus 2ac cosine of b. And the one that we just found, c squared, is equal to a squared plus b squared minus 2ab cosine of c. So this is our law of cosines.